gradient, or we call it the derivative of this function y equals to 2x squared plus 5 using the first principle formula that we established now. Now I can just deal with this. I can just solve it using this formula since I know my formula here. So all I need to find for using my formula is to find this portion, which is f of s plus change in s minus f of s. How do I slot in this particular function? This change in s is a notation. It doesn't have a value it represents, but we're going to use it. So let's deal with it using this. Now the first one is that I want to find. I must establish that I must know that my y solution according to our practice solution. I must establish that my y is 2s squared plus 5. This one means that y is dependent on x. That's the meaning of this. That's the meaning of this equation. So in that case, we have gotten my f of x, which is this side of the equation of the formula, and that's 2s squared plus 5. F of x is this. This is the function of x. We are dealing with function, you know what that means. Then we have to get f of s plus change in x. That is f of s plus change in x. The meaning of this in a layman explanation is that anywhere you see s, add change in s to it. For anywhere you see f from f of s, add change in s to it. That is 2 into bracket. This is x. That's s plus change in x squared plus 5. That's the layman explanation I can give to you. So what we just do is that we deal with this one by expanding out. So let me expand s plus change in s squared. I'm going to use Pascal triangle. That is 1, 2, 1. If you are familiar with Pascal triangle, but if you are not familiar with Pascal triangle, just do your normal expansion of bracket. I'm going to use Pascal triangle because of time. This s squared plus 2s change in s plus change in s squared. So we are here, we have been able to expand our change in x here, s plus change in s. So let's continue with our computation now. Now 2 is used to multiply this, then we can say 2 into bracket s plus change in s squared. 2 will be multiplied with each of them, 2s squared, 2 times 2, that's plus 4s change in s plus 2 change in s squared. So we can have our f of x plus change in s finalized as 2s squared plus 4s change in s plus 2 change in s squared plus 5. So let's try to remind ourselves the formula. The y, the s is linked. As change in s goes to 0, f of s plus change in x minus f of x all over change in x. So substituting each of the values we have here inside the equation, we have lim change in s goes to 0. F of x plus change in s is 2s squared plus 4s change in x plus 2 change in s squared plus 5 minus, anytime you have negative at the front of that f of s, make sure you put it in brackets to avoid confusion. That is 2s squared plus 5. Then this is over change in x. Then we still have our lim, change in s goes to 0. We have 2s squared plus 4s change in x plus 2 change in s squared plus 5 minus 2s squared minus 5. 2s squared, cancel 2s squared, 5 cancel this, everything over change in x. We still have our lim, change in s goes to 0, 4s change in x, all over change in x plus 2 change in s squared all over change in s. Before you use your limitation or your lim, you have to first look at the given fraction. If you can do some basic computation on them, maybe dividing them or factorizing them. So I can divide them first before I apply the limitation. Limitation is always the last result in our computation. So this is 4x plus 2. This one will still be left with what? Changing left. Change in x. So you cannot apply your limitation now. This is 4s plus 2 and this is going to be 0. So my answer is 4x. So that's settled the first principle approach. In solving our differentiation, or differential calculus. So we're going to move to other simpler approach that we can use in solving differential calculus. Let's move on.